Hey, Mary Faith. How are you this morning?
I'm good. How are you?
I'm pretty good. I feel like I have the sniffles this morning, so if I sneeze or anything, please forgive me. I don't feel bad. I just feel like I'm going to sneeze about every 5 minutes. And I thought it was going to clear up. That's why I'm a little late to math lab. I kind of thought it was going to clear up, but no such luck. Do you want to start on the homework, or were there specific questions you had about the homework?
I actually had a question on the work from yesterday.
Okay.
On number 7.
Is that the right one? Is that the right worksheet?
Yes.
Okay. Let me get it a little bigger so that I can have room to write on it. Seems like. There we go. Okay. Number 7. You want me to just work it out, baby girl?
Yes, please.
Okay. We're doing elimination. So the first thing that you want to do is you want to look at which variable has a matching coefficients. Matching coefficients. So on this particular number 7, that's going to be your x's, and they both have a 1, and they're both positive. So that means I'm going to subtract the 2. Subtract one from the other. So x minus x, and that cancels or eliminates those, which is the goal. And then we have a minus y minus 6, which would turn that to positive, which means you've got a -1 plus 5 or plus 6 to give you a plus 5y. And then you've got -10 minus a minus 25. So that's going to turn that 25 into a positive. So you've got a -10 and a positive 25. So when there are different signs, you find the difference and take the sign of the higher. So that's going to be that positive 25. 25 minus 10 is 15. And then you're going to divide both sides by 5. And you get y equals 3. So then you'll substitute that back in to one of the two equations. It really doesn't matter which one. I'm just going to pick the top one. Add 3 to both sides. And you get x equals -7. So the answer is -7, 3.
Thank you.
Thank you. Any other ones on that particular worksheet?
No, ma'am.
Okay, great. So you want to start on today's homework?
Yes, please.
Okay. Good morning to everybody else who's joined us. Sorry I'm a little late. I was telling Mary Faith that I had some sneezing fits, and I was hoping that they would clear up, but they haven't really yet. So I'm sorry if I sneeze on y'all this morning in math lab, and hopefully you can understand me. Okay, so the first view, basically what we're doing today is reviewing all of the different ways to solve systems of equations. We're going to do graphing first, substitution second, and then elimination thirdly. And what I'm going to try to do is do at least 2 from each section. So if you have a preference as to which one you want me to do, please let me know. Is there a preference on these? I think I'm going to try to do number 1 and number 4 with the graphing. So if you have a preference and you want me to do a different one than 1 and 4, let me know. Okay. First of all, when solving systems of equations by graphing, you need to make sure that your equations are in slope-intercept form, which is y equals mx plus b. And on number 1, neither of the equations are in slope-intercept form, so that's going to be the first thing you're going to want to do. So I've got 4x minus y equals 3. So I'm going to get 4x over to the other side. You can't just move it. You have to actually use the inverse operation. And so that's why we subtract 4x from both sides. And now we have minus y equals negative 4x plus 3. Divide everything by negative 1 because your y can't have a negative or an opposite sign on it. So that's going to give us y equals negative 4x divided by negative 1 is going to be a positive 4x. Basically, it just changes the sign of every one of the numbers. And so the positive 3 goes to a negative 3. All right, so the first one rewritten in slope-intercept form is y equals 4x minus 3. I'm going to erase this one and give myself some room to do the second one. So the second one, 3x plus y equals 4 minus 3x minus 3x. It leaves you with y equals negative 3x plus 4, which is in slope-intercept form. So, all right, now on this first one over here, we're going to go to graphing. The y-intercept is negative 3. So I'll go down 3 from the origin. 1, 2, 3, and mark that spot. Now my slope is a positive 4. So that means I'm going to travel in either 2 positive directions or 2 negative directions. Positive directions are up and to the right. Negative directions are down and to the left. Just like if you all want to think about it this way, a number line. When you go right, that's positive. When you go left, that's negative on a number line. And so it's the same thing with graphing. Graphing is just 2 great big number lines, really. I don't know if that helps or not, but it is a great big number line. So going up 4 and right 1, because remember, the slope is a ratio. So if it's just a whole integer, you always put it over 1. So up 4, right 1. 1, 2, 3, 4, right 1. And then 1, 2, 3, 4, right 1. 1, 2, 3, 4. And I always recommend trying to do several spots on this because you never really know where that intersection is going to take place. So try to cover your graph with some points. 1, 2, 3, 4, left 1. And I really can't go down 4 anymore. So I'm just going to connect my dots from here, my points. All right, so there's line 1. Now let's graph line 2. The slope the y-intercept, is 4. So I'm going to start there. That's always my starting point, that slope, the y-intercept. 1, 2, 3, 4. All right, and now the slope on this one is a negative 3. So that means I'm going to travel in one positive direction and one negative direction. So if I go up, that's positive. So that means I have to go left. And if I go down, that's negative. So I would have to go right because that's positive. So up, 1, 2, 3, and left. 1, 2, 3, and left. But if I go down, 1, 2, 3, and right, oh, look at that. I'm writing over one of my other points from my other one. So that's probably my winner. 1, 2, 3,
I'm confused. Why are you going up first?
Remember, you can go up as long as you go left. You travel in one direction negative and one direction positive. So if I went up, I would have to go left, right? You could have gone down first. It doesn't make any difference. You just have to make sure. Okay. And 1, 2, 3. Right. So if I go down, that's negative. But then no matter what, you have to travel one direction negative, one direction positive when your slope is negative. Because remember, a negative and a positive together make a negative. But, a lot of times before I did say, hey, go ahead and graph and head towards your other point. So you could have done that if you wanted to. So the winning point is right here where they intersect, right? And that point is 1, 1. And let's take a look at one other thing while we're on number 1. Something that I've said is when the slope is positive, your line should run from the left to the right. It should go up, just like that one does. And when your slope is negative, it should fall from the left to the right. Positive rises from the left to the right. Negative falls from the left to the right. So those are all some different ways that you can kind of check yourself, okay? I'm actually, hang on just a minute. Yeah. Okay, let's do number 4. All right, so they have to be in slope-intercept form, and neither one is. So we got, oops. It's moving. Okay, neither one is, so we're going to write x minus 3y equals 3. And we have to get x to both sides. You can't just move it. You have to use inverse operations to get it over there. And the inverse of positive or addition is subtraction. So you've got negative 3y equals negative x plus 3. And now we want to divide everything by negative 3 in order to isolate that y or get it by itself. So now we've got y equals, and the understood coefficient of x when there isn't one is 1. So we've really got a negative 1x divided by a 3. So that's going to give me a positive 1/3 x. And then 3 divided by negative 3 is minus 1. So this first equation here is y equals 1/3 x minus 1 in slope-intercept form. All right, this next one, 2x minus 6y equals negative 24. So not in slope-intercept form, so I need to subtract 2x from both sides. That gives me negative 6y equals negative 2x minus 24. I'll get that off my graph here in a minute. Now I'm going to divide everything by negative 6. And that's going to give me y equals a negative 2 divided by negative 6 is positive 1/3 x. And negative 24 divided by negative 6 is a positive 4. So that second line in slope-intercept form is y equals 1/3 x plus 4. Now, a bit of review from last semester is you should notice at this point that both of these lines have the same slope. And what do we know about lines with the same slope? Anybody? Anybody remember? If two lines have the same slope, what do we know about them?
Does that mean that they're parallel?
Yes, ma'am. Good job, Mary Faith. It does. It means that they are parallel. So these lines are probably not going to intersect. You can kind of see that once you get them in slope-intercept form. You can check that out. So means if they're not going to intersect, there's not going to be a solution, right? But we're going to go ahead and graph them just to kind of prove that. But you kind of know it going in. 1, 2, 3, 4. We're going to start with that second equation, and its y-intercept is 4. Its slope is 1/3, and it's positive. So that means we're going to travel in either two positive directions or two negative directions. So if I go up 1, positive direction is right. 1, 2, 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. If I go down, that's negative. So I would have to travel in a second negative direction in order for it to come out to be a positive slope. So 1, 2, 3. Left is negative. Down 1, 1, 2, 3. Down 1, 1, 2, 3. Just like a number line, if you go left on a number line, you know that you're traveling toward your negative numbers. All right, so that's one line. And then the other line, the y-intercept is -1. So we'll go ahead and plot that. And once again, it has the very same slope. It has a positive 1/3 slope. So if I go up 1 and right 3. Up 1, right 3. Up 1, right 3. If I go down 1, that's negative, so I would go left 3. Down 1, left 3. And you see after you graph them that they are indeed parallel. So that means no solution. All right. 5, I believe it's 5, 6, 7, and 8 are all substitution. Does anyone have a preference as to which ones I should do there? If not, I'll just pick some.
Can you do number 6?
Number 6, I sure can. And I'll let somebody else pick the other one. But yeah, I'll start with number 6. Okay, with substitution, the first thing you want to look for is what term has a coefficient of 1. Which equation has a term in it that has a coefficient of 1?
The bottom one?
Okay, well, I'm sorry, the bottom one. Good job. And that would be the y term. So I want to get y all by itself so that I can get an expression to substitute in. So in order to do that, I'm going to set up the equation, and then to get y by itself, I need to subtract 7x from both sides because I can't just move it. I have to use inverse operations to get it to the other side. So now I have y equals -7x minus 8. So now I have an expression of what y equals. So I will substitute that expression, negative 7x, or those terms, that binomial term, I will substitute it in for the y in the previous equation. So I will substitute 2x, because on this one, with substitution, the key to remember is you do have to plug the expression. Like when you redo the equation and isolate the one variable by itself, you want to plug this into the other equation. So this would have to go into this one. So 2x, remember with elimination, it doesn't matter as much when you find the value for an x or a y. But with substitution, it does matter which one you substitute it back into. I hope that made sense. All right, so now we plugged in negative 7x minus 8 in for the y in that first equation. And now we'll distribute the 5. The 5 times negative 7x is negative 35x. A positive 5 times a negative 8 is a minus 40. We'll combine like terms on this side. So that gives me a negative 33x minus 40 equals 7, negative 7. Now I'm going to add 40 to both sides. Negative 33x equals a positive 33. Because when I add or combine a negative 7 and positive 40, I get a positive 33. Now I'm going to divide both sides by negative 33. And I get x equals negative 1. And now I'll take that negative 1 and substitute it back in to, at this point, it doesn't really matter which one you choose when you're substituting just the value of x. But when you're the first step in substitution, it does matter. So I'll take that negative 1 and substitute it back in. 2 times negative 1 plus 5y equals negative 7. Negative 2 plus 5y equals negative 7. Add 2 to both sides. And I get 5y equals negative 5. Divide both sides by 5. And y equals negative 1. So the place at which these two lines would intersect, if you were to graph them, is negative 1, negative 1. Is there another one that you all would like for me to do in particular? Anyone?
Can you do number 9?
I can do number 9. Is there another substitution one that you all would like me to do? I can always go back, but since somebody asked for number 9, let's go for that. Happy to do it. Okay, so elimination. The first thing that you want to do is look for coefficients that either match or are opposites of each other. In the case of number 9, we have ones that match on the x-coordinate, and then we have ones that are opposite of each other on the y, because the y is in the first equation is a positive 1, and in the second equation it's negative 1. So which one would you pick if you were doing this? Ellis, which one would you pick? Would you pick? I'm sorry?
Would you pick the x?
Either one. It's fine. if you picked the x, then you're going to subtract the 2. If you picked the y, you would add the 2. That's the only difference. If the signs are the same, you subtract one equation from the other. If the signs are opposite of each other, you add them. So either one is fine to pick. You just have to tell me in Math Lab which one you guys want me to do. Anybody have a preference? I just want you guys to know it's okay to do it either way. Or I can even show you guys both ways.
Can you do the x?
I will be happy to do the x. Okay, the x's have the same coefficient and matching signs. So I'm going to subtract. So x minus x, that eliminates those. Now we have y minus a minus y, which turns that to a plus. So I have y plus y, which is going to equal 2y. And now I have a negative 5 minus 9. So that's going to give me a minus 14. I'll divide both sides by 2, and y equals negative 7. So now I'll take the negative 7 and plug it back in. X plus negative 7 equals negative 5. Add 7 to both sides, and that gives me 2. So the answer is 2, negative 7. Okay. Any others in particular?
Can you do number 10?
I can. Okay. So we're looking for matching coefficients, and we don't have any. So then the next step would be, okay, are any of the coefficients multiples of each other? Well, one is obviously a multiple, one obviously has multiples all over the place because anything times itself, anything times 1 is itself. So I would say what we want to do here then is multiply this top equation just by 2 in order to get the x's to match. So that's going to be 2x plus 10y equals 40. So I'm just going to bring that down here. I forgot to write the y, didn't I? Bring that down here. And now my x's match. I've got 2x and 2x. Both of the coefficients are 2, and they're also positive, which means I need to subtract. 2x minus 2x, those eliminate. Negative 7 minus 10y is negative 17y. And negative 45 minus 40 is negative 85. Divide both of those by negative 17. And you get y equals positive 5. Plug in 5 into one of the two equations. It doesn't matter. I usually try to pick the one with the smallest numbers. Keep it simple where you can. X plus 5 times 5 is 25.
Miss Sparks, why is it negative 17?
So I've got negative here, right? And then negative 7 minus a positive 10 makes it a negative 7 minus 10. So you've got a minus minus, right?
Okay, that makes more sense.
Okay. Good question. Got to watch your signs on these all the time, don't we? Subtract 25 from both sides, and you get -5. So if we were to graph these two equations, the place at which they would intersect is -5, 5. Okay, any other questions?
Miss Sparks, can you do 11?
I absolutely can do 11. Okay, on this one, first of all, we want to see if there's any matching coefficients. We find that there are none. The second thing that we want to think about is, are there any terms where the coefficients are multiples of one another? And that, in fact, does not happen on this one. So the next thing that we want to do is go, okay, what are the smallest numbers that I can multiply both of these equations to make the coefficients match? Well, the two smallest numbers are the ones on the y. So that means I need to multiply this top equation by 4 and the bottom equation by 3, because that would make those the least, common multiples of one another. So I've got to multiply everything in the top equation by 4 and everything in that bottom equation by 3. So 4 times 4x is 16x, and 4 times 3y is 12y, and 4 times -1 is -4. And 3 times 5x is 15x. And 3 times 4y is 12y. And 3 times 1 is 3. So now I have matching coefficients on my y term. And the preceding sign is positive. So that means I need to subtract them from each other. And 16 minus 15 is 1, or x. My 12 y's cancel or eliminate, which was our goal. And then -4 minus 3 is -7. So now I want to substitute 7 back into one of my two equations. I'm going to pick the one with the smallest numbers. Once again, keep it simple where you can. And I substitute that -7 in for x. So 4 times -7 is -28 plus 3y equals -1. I'm going to add 28 to both sides. I've got 3y equals 27. Divide both sides by 3. And I get y equals 9. So the place where these two lines would intersect, or the solution to this system of equations, is -7, 9. And you need to remember, when you're doing these, make sure you write down the final solution set, the ordered pair that makes it a solution. Okay. Are there any other questions on classwork or homework? Any graphing or substitution?
I need more help on the graphing.
More help on the graphing. Okay. Okay. What do you think is the part that's hardest for you for graphing? So I make sure I emphasize that. Is it getting it into slope-intercept form, or is it just the slope itself?
Just like looking at it and knowing what to do.
Okay. All right. Well, so the first thing, and maybe just writing down these steps. First thing, make sure it's in slope-intercept form, which is your y equals mx plus b. That's the very first thing. You can't graph a line, really. At this point in our learning in math, you really can't graph a line without it being in this format. So that's the first thing you want to do is identify, is the equation in that format? And if it's not, first thing you need to do is get it in that format. So now we have 5x plus 2y equals 4, and it's definitely not in that format. So I need to subtract 5x from both sides because you can't just bring it over. You have to use inverse operations to do that. So now I have 2y equals negative 5x plus 4. Divide everything by 2 because you've got to isolate that y. And that's going to give me y equals, and then I've got a negative 5 halves x. There's my slope. And then 4 divided by 2 is 2. So this equation in slope-intercept form is negative 5 halves x plus 2. So that's the very first step of being able to graph. How do you feel about that? Is that a part that you feel good about, or just need more review on that as well? Feeling better?
Yes, that helped a lot.
Okay. All right, good. So now that second equation, it's not in slope-intercept form either, because slope-intercept says that my y is going to be on one side of the equation and everything else is going to be on the other side, okay? So we know for sure that this one is not in slope-intercept either. So we're going to go 3x plus 6y equals negative 12. So we're going to subtract 3x from both sides, because you can't just bring it over. You have to use the inverse operation. 6y equals negative 3x minus 12. All right, now to get that y further by itself, you've got to divide everything by 6. So we got y equals, and now negative 3 divided by 6 reduces to negative 1/3 x, and negative 12 divided by 6 is negative 2. So this second equation is y equals negative 1/3 x minus 2 in slope-intercept form. And you cannot graph equations without them being in slope-intercept form at this point. We've learned some different ways, and that's where you can actually set up an XY table and all of that, and determine values by plugging them in. We learned that way. But in order now, yeah.
Why is the 6
I'm
over
sorry?
3? Why is the 6 over 3 a negative 1/3 instead of a negative 1/2?
Oh, because Miss Sparks did it wrong. Thanks for catching me. You're a sweetheart. I appreciate that. My apologies. Thank you so much, Mary Faith. Bless you. Watching me like a hawk. That's what y'all need to do. All right. So now, thanks to Mary Faith, both of these are in the appropriate slope-intercept form. Okay? Got to make sure you do the math right. All right. So on that first equation, what's our y-intercept on the y equals negative 5 halves x plus 2?
2.
Good job. So you'll plot that first. That's always the first thing that you do. And now what is your slope on that one?
Negative 5 over 2.
Good job. It is negative 5 over 2. So that means I have to travel in one direction positive and one direction negative, because it can be represented either of these two ways. That can be positive on the top. That was supposed to be positive. positive on the top and negative on the bottom. Or it can be negative on the top and positive, vice versa. I don't remember now which way I said it first, but just that you have to travel in one direction negative and one direction positive. So what is on the y-axis, the up and down axis, which direction is positive?
To the right.
On the y-axis, up or down? I'm sorry. I didn't preface it well enough. Up or down is positive?
Up.
Good job. Up. So in a negative slope, if I go up, I've traveled positive. So which direction do I need to go negative?
Down.
Well, yeah, on the y-axis. But now if I've traveled up 5, will I go left 2 or right 2?
Left.
Left. Because if I go up 1, 2, 3, 4, 5, that's positive. So now I have to travel in a negative direction because it's either going to be positive 5, negative 2, or negative 5, positive 2. Is that making more sense to you guys?
Yes, ma'am.
Okay. So if I go down 1, 2, 3, 4, 5, that's negative. Down is negative. Right is positive. Down 1, 2, 3, 4, 5. Right is positive. Okay. So, and then once again, once I graph this line, I want to double check and look at it. Okay, I remember. Oh, it's not even on the thing. Hold on. I remember that with a negative slope, my line still not. I can't draw a straight line. It needs to fall from the left to the right. And it does. So we start in that upper left quadrant and it falls to the right. And so I know that it's graphed with a negative slope as long as I calculated everything right. All right, so line number 2, what is the y-intercept?
-2.
-2. Good job. What is the slope?
-1/2.
-1/2. Good job. So that means when I'm graphing this, I'm going to do -1/2, or I can do +1 over -2, because a negative divided by a positive or a positive divided by a negative is still a negative. So if I travel in a positive direction first, I need to make sure I go in a negative direction next. So if I go up, which is positive, I need to go left 2. If I go up 1, I need to go left 2, because left is negative. Up is positive, left is negative. If I go down 1, right 2, because down is negative, right is positive. Down 1, right 2. Down 1, right 2. Let's see if I can do any better on my line. Once again, I can double check my line to make sure I graphed it with a negative slope by seeing that it falls from left to right. If it's long as it's falling from left to right, I know it's a negative slope. And as long as I calculated my boxes correctly, I've done it correctly. And we have an intersection point right here. And what point is that? Can anybody tell me?
-2, -3.
It is -3 and it is a 2, but I've gone this way on the line. So this is positive.
So it's +2 and -3?
Yes. This part, this is just like a number line. And this is like your 0 point on your number line. So on your x-axis, all of these numbers over here to the right are positive. All of these numbers over here to the left are negative. Just like a number line. And this, the y-axis kind of is your 0 point. And all of these above here, oops, let me do that in the same color. All of these are positive on the y-axis and x-axis. All of these are negative. So if you count to the right and go down, your x coordinate is going to be positive and your y coordinate is going to be negative in this quadrant here. So like over here, both are going to be positive. Over here, your x is going to be negative and your y is going to be positive. In this quadrant, both coordinates are going to be negative, and in this quadrant, the x is going to be positive and the y is going to be negative. Does that help?
Yes, ma'am.
Okay, you want me to do one more?
Yes, please.
Okay. All right. On number 3, neither one of those are in slope-intercept form, are they? Hopefully Mary Faith is there to check my math. Thanks for having my back, Mary Faith.
You're welcome.
Are you still with me? Okay, good. All right, so let's get that in slope-intercept form. We have 2x plus y equals 1. So to get it in slope-intercept form, we got to subtract -2x from both sides because you can't just bring it over. So now we have -2x plus 1. So that's in slope-intercept form now. And now we'll work on that second one to get it in slope-intercept form. X minus 2y equals 18. Subtract x from both sides. We have -2y equals -x plus 18. -2, divide everything by -2 to further isolate that y. And then we've got y equals, and then there's an understood 1 right here. So I've got -1 divided by -2. So that's going to be a negative divided by a negative is always a positive. So that's going to be a 1/2 x. And then 18 divided by -2 is -9. Right, Mary Faith? Did I do it all right?
Yes, ma'am.
All right. So for this one, slope-intercept is y equals 1/2 x minus 9. And something cool about this one. I know they're going to intersect for sure. The slopes are opposite reciprocals of each other. Do you all remember what kind of lines those are when the slopes are opposite reciprocals? How do those two lines? They do intersect. You're absolutely right. They will intersect, but they're special.
Vertically? Or no?
If they're not parallel, what other type of lines did we learn about last semester? Bringing back some stuff from last semester. You'll have to have this for geometry next year. That's why I'm reminding you. What other type of line did we learn about besides parallel last semester?
Continuous.
They can be parallel or what?
Perpendicular.
Perpendicular. Good job. Perpendicular. Absolutely. And these two lines are perpendicular of each other because their slopes are opposite reciprocals. So lines with the same slope are parallel, and lines that are opposite reciprocals of each other are perpendicular. And you will definitely need that for geometry. It's used quite a bit in proofs and other things. So good thing to kind of remember and hang on to. All right, so back to the graphing. We have y equals negative 2x plus 1. So in this one right here, what is the y-intercept?
What was the question again?
What is the y-intercept on this equation right here?
1.
1. Good job. All right. So that it's a positive 1, so it's going to go above the origin. Plot that first. And what's my slope?
Negative 2.
Okay, so that means I'm going to travel in one direction negative, one direction positive, because it's a ratio, and it's either negative 2 over 1 or it's positive 2 over negative 1. Okay, so if I go up 2, 1, 2, I would have to go left 1 because up is positive, 1, 2, left is negative. Up 2, left 1. Up 2, left 1. If I go down 2, which that's a negative direction, I would go right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Because you want to make sure that you're traveling one direction positive, one direction negative when the slope is negative. Then after you graph it, you want to double check, look back at it, and see that it falls from left to right if it's negative. All right, that second line, what is the y-intercept on it?
Negative 9.
Negative 9. Good job. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's way down here. Falls below the origin because it's negative. All right. And the slope is what?
1 over 2.
1 over 2. And it's positive. So with a positive slope, you're going to travel in two positive directions or two negative directions because a negative divided by a negative is still a positive. So if I go up 1, I'll go right 2. Up 1, right 2. Looks like that's where they're going to connect. Up 1, right 2. Up 1, right 2. Up 1, right 2. But if I went down 1, that's negative, I would have to go to the left. So these lines intersect right here. What are the coordinates for that point?
Can you repeat the question?
What are the coordinates for the point where they intersect? What's that, where the black dot is? What are the coordinates of that point?
5 and -9. Oh, wait, no, sorry. 5.
7, 4.
We're over 4. Yes, 4 is correct. But we went down what?
7.
7. So that makes it positive or negative if I went down?
-7.
Negative
So
7.
4 and -7.
So the coordinates are 4 and -7 because I went right on the x-axis, which makes that positive, but I went down on the y, which makes that negative. Remember, in this quadrant right here, my x is going to be positive and my y is going to be negative. So the solution to that system of equations is 4, -7. And they were perpendicular lines. Nice review. We had parallel and perpendicular lines on 3 and 4. So good review. That's going to come up in geometry for sure. Y'all will need to know that. All right. Any other questions?
No, ma'am. Thank you.
You're welcome.
Thank
Have
you.
a blessed day.
You
You too.
too.
All righty. Take care.
You too. Bye.
Bye-bye.